What if the Big Bang wasn't the beginning? What if it was just a door? On one side, the universe we know, on the other, something that came before. Something that died so we could exist. A Nobel Prize-winning physicist believes he's found proof, and it's hiding in the oldest light we can see. When astronomers first pointed the James Webb Space Telescope at the ancient universe, they expected to find cosmic infants, tiny, fragile galaxies just learning to form their first stars. Instead, they found monsters, galaxies so massive and so mature that they shouldn't exist. One of them contained as many stars as our Milky Way, yet it formed when the universe was only 3% of its current age. It's bananas, said one researcher, and that was the polite version. The standard model of cosmology has a problem, and a 94-year-old mathematician thinks he knows the solution. But it requires us to accept something extraordinary. Before we get there, let's understand the scale of what Webb discovered. These aren't slightly unusual galaxies. They're impossible by every calculation cosmologists had made. In the standard model, the universe spent its first few hundred million years in darkness. Hydrogen atoms drifted through the void. Gravity slowly pulled them together. The first stars flickered to life, small and blue and violent. Galaxies built themselves piece by piece, merger by merger, over billions of years. But Webb found galaxies that skipped the line, fully formed, chemically mature, containing old red stars that should have taken billions of years to evolve. One galaxy, cataloged as GZ9P3, appeared as nothing more than a speck through Hubble. Webb revealed it to be 10 times more massive than anything else from that era. It wasn't just big, it was impossible, and it wasn't alone. How do you build a galaxy that fast? You can't. Not unless the rules were different. Not unless something gave the early universe a head start. To understand what Roger Penrose is proposing, we need to start with what happens at the end. Not the end of a star or a galaxy, but the end of everything. In the far future, trillions of years from now, the universe will be unrecognizable. Every star will have burned out, every planet will have frozen, every black hole will have evaporated through Hawking radiation, converting their mass into an endless stream of photons. The universe will become a cold, empty sea of light. Nothing with mass will remain. Here's where it gets strange. In a universe with only massless particles, something bizarre happens to time and space. Without mass, there's no way to measure distance, no way to measure duration. The concepts themselves become meaningless. A universe that's infinitely large and infinitely old becomes mathematically identical to one that's infinitely small and infinitely young. Let that sink in. Penrose calls this a conformal rescaling. The dying universe, stretched beyond comprehension, can be mathematically mapped onto a single point, a point that looks exactly like a Big Bang, not metaphorically, mathematically. The end of one universe becomes the beginning of the next. Death becomes birth, and then it happens again, and again, forever. This is conformal cyclic cosmology, or CCC. Penrose published the theory in 2005 and expanded it in his book Cycles of Time in 2010. Most cosmologists dismissed it as elegant mathematics with no connection to reality. The idea seemed untestable. How could we possibly detect evidence from a universe that no longer exists? But Penrose wasn't finished. He went looking for proof, and in 2018, he announced he'd found it. Remember those hot spots in the oldest light we can see? The cosmic microwave background is the afterglow of the Big Bang itself, a snapshot of the universe when it was only 380,000 years old. It should be nearly uniform, with only tiny random fluctuations, but Penrose and his colleagues found something else. Circular patches of unusually high temperature, about 3 to 4 degrees across on the sky, appearing in locations that match no standard explanation. Penrose calls them Hawking points. The name honors his longtime collaborator Stephen Hawking, who proved that black holes slowly evaporate by emitting radiation. According to Penrose's theory, these circular hotspots are the final signatures of supermassive black holes from the previous universe, black holes that evaporated over countless eons, concentrating all their Hawking radiation into a single point. When that previous universe ended and became our Big Bang, those concentrated energy points left an imprint, a cosmic fingerprint from a dead universe, pressed into the infant fabric of our own. The idea is extraordinary. The controversy is fierce. A 2020 reanalysis claimed the supposed Hawking points were statistically consistent with random noise once all variables were accounted for. The researchers argued that if you look hard enough at any random dataset, you'll find patterns. The human brain is wired for it. We see faces in clouds and constellations in random stars. But Penrose pushed back. In March 2025, he and his colleague Christoph Meissner published new research, refining the mathematics and arguing that the temperature signatures match the expected masses of galactic clusters with remarkable precision. The amount of heat in each Hawking point, they claimed, corresponds to what you'd expect from the evaporation of the largest black holes in the previous universe. The numbers line up. That's either an extraordinary coincidence or an extraordinary discovery. The debate continues. Most cosmologists remain skeptical. But Penrose won the 2020 Nobel Prize in Physics for his work on black holes, proving that singularities are a necessary consequence of general relativity. He's been right before when consensus said he was wrong, and he has a track record of seeing mathematical truths decades before experimental evidence catches up. Now consider the James Webb problem again, those impossibly massive early galaxies. The standard explanation is that we're measuring them wrong, that black holes at their centers make them appear brighter and more massive than they really are. And that's probably true for some of them. A study in late 2025 showed that many of the universe breakers were optical illusions created by actively feeding supermassive black holes. But not all of them. Even after accounting for black hole contamination, there are still roughly twice as many massive galaxies in the early universe as the standard model predicts. Something helped them form faster than it should have been possible. What if the universe was already primed? What if matter coalesced faster because the initial conditions weren't truly random, but carried some faint structure from what came before? In CCC, the gravitational waves from the previous universe could have influenced how matter clustered in our own. The fingerprints of dead galaxies might have shaped the birth of new ones. The echoes of ancient black holes might have seeded the formation of new stars. This is speculation. Penrose himself is careful to note that these connections remain unproven. CCC doesn't require the Webb galaxies to be explained by previous universe influences, but it offers a framework where such influences are possible. And right now, that's more than the standard model can say. What does this mean for us? If Penrose is right, our universe isn't unique. It's not the beginning of everything. It's a chapter. One of potentially infinite chapters in a story with no author and no end. The Big Bang wasn't a creation from nothing. It was a transformation. The universe doesn't die. It forgets how big it is and starts again. There's something both humbling and strangely comforting in that idea. Every atom in your body was forged in stars. Those stars were born from gas clouds that collapsed from the primordial plasma of the Big Bang. And that plasma might have carried the faint echoes of a universe that existed before any of it. We're not just made of star stuff, we might be made of universe stuff, recycled across cosmic cycles we can barely imagine. The physicist who first proposed this is now in his 90s, still publishing papers, still challenging consensus. He worked alongside Hawking for decades, and now he's searching for Hawking's signature in the sky. He's lived long enough to see his black hole mathematics become textbook physics. He may not live to see CCC vindicated or refuted, but the question he's asking, what came before the beginning, will outlast all of us. The tools to answer it are coming. The European Space Agency is planning gravitational wave observatories that could detect the specific patterns CCC predicts. Better analysis of the cosmic microwave background with next-generation satellites could confirm or refute the Hawking points. Science moves forward by proposing bold ideas and then checking them against reality. That's exactly what's happening now. Remember those hot spots in the microwave background? Whether they turn out to be noise or signal, they represent something profound. For the first time in scientific history, we have a specific testable proposal for what might have existed before our universe began. That alone is worth pausing on. The cosmos may not have a beginning. It may not have an end. It may simply continue, cycle after cycle, each Big Bang erasing almost everything that came before. Almost. Because in those faint hotspots, in those impossibly mature galaxies, in those mathematical structures that seem to transcend time itself, something survives. If our universe dies in the unimaginably distant future, will anything we've done leave a mark? Could the light from our sun, the gravitational ripples from our black holes, the structure of our galaxy cluster, someday appear as a faint anomaly in the sky of a universe that doesn't know we ever existed? That's the question Penrose is really asking. Do you think he's onto something, or is CCC an elegant dead end? The next generation of telescopes might finally tell us. Until then, we're left staring at the oldest light in the universe, wondering if we're seeing ghosts.